are starting Unit 3, which is all about graphing. And we're starting with something that you have talked about before, domain and range. And the point of this is that when I use these words, to describe something, you are able to connect with what I'm referring to, okay? And so starting with a relation, I don't know if you've defined this before, but anyone know what a relation is in the mathematical sense? Yeah. Not a proportion. Yes?
Like, this thing is dependent on this thing?
No, it is a collection of ordered pairs. Okay, it is a collection of ordered pairs. And a relation can be represented a number of different ways. Okay, down below you see an XY table, a function table, maybe you called it last year. That is a collection of ordered pairs. Right? We have an x value of -10, a y value of -3, x value -5, y value 0. As a table, it is a relation, it's a collection of ordered pairs, right? If we graph them, we may end up with something like a line or something like a segment. These are also relations. They are collections of ordered pairs that have been graphed. What's the difference between a line and a segment? You can see it if you look at the corner planes. You also might know definitionally. Claire?
A line, like it continues forever, but a segment stops.
Right, a line goes on forever. A segment has a beginning point and an end point. And we show that by putting these arrows on it, right? The arrows that a line has means it continues on forever. The segment, if you notice, doesn't have those arrows. It's got points. So if you want to be a little bit snarky with a teacher that tells you to line up, how would you politely, respectfully correct that teacher? Lucas?
Ma'am, I do not believe we have enough students.
Okay, you could do that. How else might you politely, respectfully correct said teacher that told you to go line up? Christian?
Hey, ma'am.
Why are you assuming it's a man? Why would
We're assuming we're talking to you.
Hey, great teacher, master of your profession. Yeah.
There's not infinite amount of kids.
Okay.
I already said that.
Rowan?
You're short.
Oh. Not gonna call you anymore. Henry?
A line goes on forever, and since we do not have that many kids, we should do a segment.
We should segment up. Not line up, we should segment up. That would be the more appropriate.
Or you can
Kyle, I'm calling you.
I wouldn't say anything because if they interpret it wrong, I would get a tip.
That's quite possible. Domain. Talking about relations, the domain are the x values of a relation. The x values of a relation would be the domain. So if I'm describing the domain of a relation, I'm talking about just the x values in a table. It's just that first column, okay? On a line or a segment, you have to look at the graph. But the x values of that relation. What would you guess the range is? The y values of a relation. Okay, the y values of a relation. So our objective today is to, given a relation, be able to identify the domain and the range. Okay? So for this first one, if you can't not push the tail back and forth, then I have to push your leg down. Okay? If you can't, you can just pull it back and forth like that. It disrupts your tail domain and everything on. So for an XY table, the domain, what are the x values included in this relation? Henry?
-10, -5, 2, 1, 0.
-10, -5, 2, 4, 0. An XY table is nice because it gives them to you. You're essentially just regurgitating what that x column is, right? The range of the table, I'll kind of is the domain, R is the range until they become familiar with those. What would the range of that relation be? Kyle?
-3,
-3.
0,
Mm-hmm.
8,
Mm-hmm.
2, and 1. Or -1.
-1, yeah. Okay? Again, just writing out what those values are. So we like XY tables because they're very straightforward, very self-explanatory. They've got the domain and the range just right there for you. Okay? When it's graphed, it's a little bit different. And we're going to start with a line. So knowing that this line continues on forever and ever and ever and ever, when we're talking about the x values of this relation, we're looking on the x-axis here, right? Is there any number on the x-axis that is not represented in an ordered pair in that line? For example, if we're looking at the x value of -4, where is -4 represented in an ordered pair on the line? Go right down here, right? This ordered pair is -4, -3. The x value of -4 is represented somewhere on the line. Okay? How about the x value of 2? Where is the x value of 2 represented on the line?
0.
Nope, this is not the line. The line's right here. Okay? The x value of 2 is represented in this ordered pair right here. This is the ordered pair 2, 6. Right? There's our x value of 2. It's represented somewhere on the line. It's not to say that this line crosses the x-axis at every single number, right? Because that'd be impossible. It's saying where is each number represented in an ordered pair somewhere on the line. You see the difference there? You see the distinction? Okay? Let's do another one. Where is the x value of 0 represented in an ordered pair somewhere on the line? Yes. At the y value of 3, right? Right here is the ordered pair 0, 3. It doesn't cross the x-axis at 0, but the x value of 0 is represented. It's used somewhere on the line. Okay? So thinking about a line, the fact that it goes on forever, is there going to be an x value that's not represented somewhere on the line? No.
Yeah.
What would you think? What x value would not be represented? Even something like 7. You're like, oh, 7's not on the line. But somewhere up here, that line continues on, yes, 7 will be represented. Maybe it's, I don't know, 7, 12. Don't really care. Okay? But the point is that even something that's not shown on the graph will be represented, will be used in an ordered pair somewhere on the line. So I'll ask my question again. Is there an x value that will not be used?
No.
If the line goes on forever, no. So, like we have used in the past in PO7, what's that mathematical symbol to show everything's included?
Like the T kind of, and then R.
The double-stemmed R. Okay? The domain of a line will always be everything. Because every x value will at some point be included in an ordered pair. Is the same thing true for y?
Yeah.
Boys, you got something for me? Oh, he's just giggling. You've been giggling for like 10 minutes back there. I'm wondering what the joke was. Okay? Is the same thing true for y?
Yes.
Yes. Okay? And again, it's not looking for where does it cross the y-axis. It's saying, is every y value represented? Let's take -6 here. Okay? Where is the y value of -6 represented in an ordered pair? Right here. Here's the ordered pair -4, -6. -6 is represented. Okay? How about, well, here's +6, right? Here's where +6 is represented in an ordered pair. So just like the domain, because a line goes on forever, the range is going to be all reals as well. Every y value will at some point be a part of an ordered pair that's on the line. Okay? Not true for a segment, however, right? A segment, things changes. Things change. Because a segment does not go on forever. Okay? Things changes, yeah. Where does the x value of -3, where is that included? I'll do it in a different color because it lines in green. Where is the x value of 3, where is that included on the segment? At what order pair is 3 represented? Lucas?
3, 3.
3, 3, right? The x value of 3 is part of the segment at the order pair 3, 3. It's represented there. How about the x value of -2? Is -2 represented anywhere on the segment?
No.
No, because if we trace this -2 up, we don't touch the segment. The segment stops before it gets there. Right? So it can't be all reals because we found an x value that doesn't hit the segment. That's the difference here. Okay? So we have to look for, okay, what x values are included. Look at that x-axis. What x values are included in the segment? What's the low end? What's the high end on the x-axis there? Again, not where it crosses it, but what values are represented. Grace, your hands up first.
-1 to 5.
Exactly. From -1 to +5, every x value is represented on the segment. Okay? Does that make sense? And why can't we just write -1, 0, 1, 2, 3, 4, 5? Look, there's kind of listed things here. Why can't we just use commas and say -1, 0, 1, 2, 3, 4, and 5?
I don't know.
Well, we're going to answer that. Lucas, why?
Because sometimes we'll have some really big sets of numbers.
Sometimes what?
We'll have some really big sets of numbers.
Okay, maybe we're dealing with something that's not nice and easy fitting on the corner plane there. What else?
Decimals.
Decimals and fractions, right? Even the x value of like 1.5, halfway between 1 and 2, that is represented on the segment somewhere. So we have to include everything, all the fractions, all the decimals, every possible value between -1 and +5. So when we write the domain, -1 is the smallest x. It does not go past -1. And then everything all the way to 5. Okay, so the low end is written, the high end is written, and to show that everything in between there is also part of this, we put that arrow there. Have I lost anybody completely here?
No, I remember this kind of.
Okay, like I said, this is a little bit of review. You've had it before, okay? Now, when looking at the y values, the range here, what values on the y-axis are represented, are included in the segment? Is -2 on the y-axis, is that included in the segment?
No.
No, the segment does not go down to -2 on the y-axis. If we kind of extend that over there, it doesn't hit it. So what values are included? The y-axis. Let's come from over here. This has to be kind of quiet. Yeah, Paige.
7 through 1.
Right. 1 is the smallest y value that we have here. It stops at 1. On the y-axis, it stops at 1. Doesn't go any further than that. 7 is the highest. Everything in between here is included. Nothing above 7. Nothing below 1. So our range is going to be represented as +1 through 7.
Do you have to write the lowest number to the highest number?
I mean, I guess technically not.
Okay.
Typically it's done that way, but technically you wouldn't have to, I suppose. Question on this. All right, be ready for a loud picture because my volume is jacked up.
You do it
here.
again.
No,
Why can't you turn your volume down?
I can, I just haven't.
Just don't.
Okay, good?
I can't hear you on that.
So, the other part of this is that if I give you the domain and range, you need to be able to tell me what type of relation it is, and then represent it. Okay? So for the first one, it says make an XY table or graph with a given domain and a range. The first one, D, -4, -1, 6, 0, 2. R, 3, -4, 6, 10, and -1. What type of relation is that?
Table.
Numbers listed out with commas, what type of relation is that?
Table.
It's a table, okay? It's giving you specific values. So you would make a function table, an XY table. Your X values are -4, -1, 6, 0, and 2. Your Y values are 3, -4, 6, 10, -1. Just like that. A table is very straightforward. The second one, this is a notation you haven't really seen before. I'm introducing it to you today. When you see something like this, what that means is it's like it's saying X is between. When you have those two less than or equal to symbols there, with an X in between them, it means X is between. So what this is really saying here is that X is between -3 and +5. What does that sound like? If I'm describing the X values of a relation, I say X is between -3 and +5, what type of relation does that sound like? A table, a line, or a segment? A segment, right? This would be the same thing as writing -3 with an arrow and +5. It means the same. So, you are looking for a segment, and you need to draw your own coordinate plane, so do the best that you can there, okay? Put some 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6, 2, 3, 4, 5, 6. Just kind of sketch it there, okay? We're looking for something that on the x-axis, I see my -3 and my +5. On the x-axis, it goes from -3 to +5. This is the domain. Right? That's what that first thing tells me. That our domain is between -3 and +5. Have I lost anybody? Okay? The range is between +2 and +4. So on the y-axis, I'm looking for something that goes from 2 to 4. This is the range.
Same.
The segments I can make here, if I take the low end of both of my sections here, and put a point there, kind of where they would connect if I extended this up and extended that over. I'm kind of dealing with the low of each of there. And then I go do the same thing on the other side, kind of the high end of things. I put a point there. Here's a segment that goes from -3 to +5 on the x-axis, and from +2 to +4 on the y-axis. Another way to think about this is that recognize this ordered pair is -3, 2. Where do you see a -3 and a 2 in our given information?
I don't.
You don't? Oh, look harder.
Oh,
They're not
on
hidden.
the domain range.
They're the low end of each of these things, right? -3, 2 appears right there. That, it's not a coincidence. It's our first ordered pair right here. What's our second ordered pair in this segment?
5, 4.
5, 4. Where do you see a 5 and a 4?
Up
Right
there.
up next to
On
it.
the high end. So if you look at the low end of each of those and the high end of each of those, it's going to give you the ordered pairs that you need. Okay?
I have a question.
Yeah.
How do we know? Never mind.
Okay. Your homework for tomorrow, and please write this stuff down. I think some of you in binders, as I've been helping with practice work, things like that, you're skipping steps because when I say it, it's like, oh, that makes sense. I don't need to write it down. But, you know, you leave this classroom, you go to your next class, eat lunch, you know, do your homework at night, you come back to it in a week for your favorite test. You're not gonna remember every single thing that I said, okay? That's why we have the videos, so you go back and look. What exactly did he say? Okay? But make sure you're writing ample notes down, because even though it might make sense and it clicks now, it's good to have that reminder later on also. Your homework for tomorrow. It says write the domain and range of each relation. Now these are not lines, are they? Right? But again, a relation is simply a collection of ordered pairs. So if we're looking at this first one, is this, and I'm going to classify here, is it an XY table? Is it a line, in the fact that it goes on forever, or is it more like a segment where it has a beginning and it has an end? It's more segment-ish, right? There's no arrow on each end, which tells us it goes on forever. It just kind of stops. It starts and it stops. So we're looking for, again, for the domain, what values on the x-axis are included? A lot of numbers, but remember we have that arrow, so we have to write all of them out. But what's the lowest value on the x-axis that this relation uses, represents?
0.
0, right? 0. What's the highest number on the x-axis that this relation uses? 50. It goes all the way across, right? Every x value is represented somewhere in this relation, right? Where is 30 used? 30 is used right here. Where is 15 used? 15 is used right there. Where is 45 used? 45 is used right there, right? Every x value is used somewhere. Therefore, everything from 0 to 50 is part of the domain. Everyone see how I got that?
Yeah.
Okay? On the y-axis, it might be a little bit of estimation here. But for the range, what's the lowest y value? It's not 0, right? This does not come all the way down to 0. Where does it start? Olivia?
Would it be like 1,500-ish?
Sure. Okay? About halfway between 1,000 and 2,000. That's the lowest y value that this segment, that this relation, I should call it segment, that this relation uses. What's the highest one?
Around 8,900. Yeah,
8,800. 8,800, 8,900.
It hasn't
Sure.
really got to 9,000.
Okay? Everything in between there is represented somewhere on the relation. So your range would be 1,500 through 8,900, or if you put 9,000, that'd be fine too. Like, you know, but you're looking for the lowest and the highest x and y value here. Okay?
How do we tell if it's a line instead of a segment?
It'll have arrows and it'll be straight. Lines can't curve.
Oh, yeah.
So all of these are going to be of the segment variety.
Okay.
I should say that. If it has arrows, it does mean it goes on forever. It's not a line. But if it has arrows, it does mean it goes on forever.
Is there anything on here that has?
Yeah.
I think the fifth one does,
Yeah,
the one in
fifth
the
one
middle.
does.
This one.
Kind of tough to see. I don't know, is
Yeah, it does.
that an arrow?
Yeah, there are.
Yeah, okay.
It kind of has a
Let's start with the third one. Even if it dips down, right, you don't care what the relation looks like necessarily. You just want to know what's the highest, what's the lowest. So looking at the x-axis here, the x values, what's the lowest x value that this relation includes or uses? James? 0. It does have a 0, right? All the way up here. Okay? And then even though it dips down, is it still moving across horizontally? Yeah. What's the highest x value? 12. So everything from 0 to 12
Oh, yeah.
is part of the domain. You're not looking at the shape necessarily. You're looking at what x values are being used. Everything from 0 to 12 is being used. How about the y-axis? Are we going to start our range with a 7? Or start our range with a 1?
1.
1. Why the 1? Olivia?
Because like it dips, since it like dips down, because then one would be included, so it would have to go just 7 to 13.
Right.
But since it dips down, we have to start.
Exactly. What's the lowest y value that this relation uses? It doesn't matter where it starts. Because it dips all the way down to 1, that's the lowest y value that's being used. What's the highest one? Give or take. 13-ish. 13.2, you know, whatever. But everything between here and here is being used. Even though it moves around a little bit, everything there's being used. So our range would be 1 to 13.2 or whatever you want. Okay? So, your assignment. Jeez Louise.
I'm done.
Your assignment is to finish the second page here. We have 6 more, or 4 more for you to do. How can you tell the difference between a segment and a line when looking at it on the coordinate plane? And then what is the domain and range of a line? We haven't talked about lines in a while, so we know that one back on there. Any more? Is it a 3-pager? No, it's only a 2-pager. Questions, comments, concerns, complaints, comments, congratulations, criticisms on this? Kyle?
Congratulations, it is voting day and my mom's birthday.
Oh, well, very good. Congratulations. All right, with gusto, folks, that's how you math.